Okay, this is problem number 15 in section 5.8. We're going to use u substitution. Here we have two square root functions, and instead of choosing inner function as u, it's better to choose one whole square root expression as u, so that because if you choose suppose you choose just this as u, the square root is still going to be there, and the other square root will also be there, right? So still it's not simplified. The idea in using u sub is to get a simpler expression involving u, which is ready for formula. So we're not going to do this. Right, so I will choose one whole square root as u. Either you could use choose this as u, or the other square root will also work. So I'm going to use u equal to square root x as u. First part is the derivative part, so we're going to do du. This is going to be x to the half, so half x to the negative half dx. Rewriting it, we will have 1 by 2 to the x power half dx. So we can still rewrite this using this one, where u equal to x power half. So we will rewrite this as du equal to 1 by 2u times dx. Okay, so now we are ready to rewrite the given integral. So we're going to rewrite part by part. So we have 1 in the numerator. This part becomes u. Now I will copy this as 1 over the square root of 1 minus x. We will replace this in the next step. And then I'm going to replace dx. Dx, we're going to get it from here. Right? So dx equal to, push the 2u to the left side. So this will become 2u du equal to dx. So I'm going to put 2u du. So u cancels. We still have square root of 1 minus x because we want to convert the integral entirely with u as the variable. There should be no x in the integral. So we're going to use go back to the relation between u and x. U equal to square root of x, and we want to get square root 1 minus x. So u squared equal to x, squaring both sides. And we want, so from there, now we are ready to write this square root of 1 minus x equal to u squared. I will pull the 2 outside, du. Right? So we have this integral. This integral is ready for formula, which is the arc sine formula. Formula number 17. So this is going to become arc sine u by a. A is 1 in this case. Replacing by x, 2 arc sine u equal to square root x plus c. Okay, let's look at problem number 19. This is a problem, and we're going to use the u sub. There is only one square root, so you could try the whole inner function as u, but that may not work. So I'm going to kind of choose this as u. The idea behind this is the formula. We have square root of a squared minus u squared du. Right? So we have a formula of this form where we have a square root in the denominator and a squared minus u squared, a constant, which is 9, and this could become u squared. Right? So that is the idea. Maybe with this this whole integral might transform to this 1 over square root a squared minus u squared form. Right? So instead of choosing the whole inner function as u, the whole the whatever is under the square root as u, it's better to choose just u equal to x minus 3. Right? So the denominator will become 9 minus u squared, and probably this will simplify to one of those last few formulas. Right, so we're going to work with this u, du equal to dx. Right, so rewriting every part of the given integral. denominator is the square root of 9 minus u squared. Dx is du. So there is still x plus 5 to be replaced. So we're going to get x from here. So from here, x equal to u plus 3, moving the 3 to the other side. But we want x plus 5 in the numerator. So x plus 5 equal to u plus 3 plus 5, which is u plus 8. So this will become u plus 8. So we have the integral completely in terms of u. We want to see if there's a formula that can be readily applied. But there's no such formula. So we're going to split the fraction. Right? So if you split the fraction, it's going to become 1. The first term, u over square root of 9 minus u squared plus 8 over square root of 9 minus u squared. Right? So this fraction is split into these two fractions, and this is going to become two integral problems. So the first integral is u over square root of 9 minus u squared du. Second integral is integral 8 over square root of 9 minus u squared du. Alright, so we have integral 1 and integral 2. Okay. Integral 2 is a ready to apply formula, because integral 2 will become, I will put integral 2 here. Integral 2 is 8 over square root of 9 minus u squared du. We can pull the 8 outside, and 1 over square root of 9 minus u squared du. So this is our arc sine formula. So next step is just applying the arc sine formula. Arc sine is 1 by a. A is the a3 here. Arc sine u over 3. This will simplify to 8 by 3. Arc sine, replacing u is x minus 3. X minus 3 over 3. Right? So this is integral 2. Right. So we're going to work on integral 1, and this is integral 1. Okay, so this is integral 1. So integral 1 is, we want to first observe that there is a u squared in the denominator and a u in the numerator, right? So which is a derivative of u squared. So another substitution is required here. So we're going to substitute v equal to 9 minus u squared. So the inner function in this is becomes the new substitution. So we already have u, so I'm using a new variable v. Another substitution technique here. dv equal to minus 2u du. So u du will become negative half dv. Right. We are ready to put all this back into this integral. So this integral will become integral. Denominator is square root of v. And then we have u du. U du is negative half dv. Right? So this is completely an integral in v. We'll pull the half outside. And v to the negative half dv. Ready for the power rule. This is going to become half v to the positive half by half. So this will become half gets cancelled. Negative half 2 by 1. V to the half is going to be just square root v. So we're going to go back to v. From v you have to go back to u, and from u you have to go back to x. So negative square root of v. This will become negative square root of v is 9 minus u squared, and from which we have to go back to x square root of 9 minus u is x minus 3. X minus 3 the whole square. Right? So this is the integral 1. So we have integral 1 plus integral 2. integral 1 was square root of 9 minus x minus 3 the whole squared, plus you can simplify this part, 8 by 3 arc sine x minus 3 over 2 plus c. This is problem number 46 in section 5.8. This problem is easy to start with because u is already given in the problem, right? So we're going to work with this u. Derivative part, du equal to, this is going to be x plus 1 to the half. So half x plus 1 to the negative half dx. So du equal to 1 over 2 times x plus 1 to the half dx. Now replace this by u. So this is going to become 1 by 2u dx du. So pushing the 2u to the other side, 2u du equal to dx. Alright, so we're going to go back to the integral. The dx, I will put the dx here. Dx is 2u du. So we have the 2 in the denominator. I will write 3 minus x. Next step I will replace this, and square root x plus 1. Square root x plus 1 is the u. Alright, so now we could just cancel the 2u. So we have integral 1 over square root 3 minus x du. It has to completely be transformed to integral in u. So we're going to go back to the relation u equal to square root x plus 1 to transform the integral to u. So we're going to get u here, u squared equal to x plus 1, u squared minus 1 equal to x. We want 3 minus x. So 1 over square root of 3 minus u squared plus 1 du. Okay, so substituting this x here, this will become integral 1 over square root of 4 minus u squared du. Now the integral is transformed entirely in u. This is ready for formula, arc sine formula, where a equal to 2. So we have 1 by a arc sine u by a, going back to x, 1 by 2 arc sine u is square root of x plus 1 over 2 plus c.